We are live.
Yep, and we are live. Hello, everyone. Thanks for joining us on a Friday evening in October, and it's surprising that we've reached so far already. Right, we started all the way in July, and we're here already. So thanks for joining us today. We're going to be talking on securing serverless applications. We're going to keep it simple. So it's more about the theory because we could. What we are going to do is take a lot of these concepts and then build it out in future workshops and maybe series and seminars and all, which will happen in the future. But the key thing is just to leave you with some of the theory so that you can start looking at it. If you're already building projects, then you can consider and take that as guidelines of how you can secure your applications better. So I'm Fuzz. I'm a senior solutions architect for startups. Been 16 years in this industry. Worked across multiple domains. Engaged in software development, infrastructure automation, DevOps, and even managing teams. I also build developer communities, and I've been talking and practicing about serverless since 2017. So I'm one of those guys who, if you come to me and ask me, okay, should I host it on a server? I'll ask why, and then we'll start the conversation from there. So that's kind of like where I come from. From a series perspective, I mean, we've been doing this from July. We started on the 3rd of July and we spoke a lot about the building blocks. A lot of our videos are already available, and we will be sharing a place where you can actually refer to these later, maybe in the Telegram group or elsewhere. And the idea is that we initially started these talks. I started most of the building blocks, but then we had guests coming in who would talk about some of these building blocks from their perspective. So we had Ped from Photobook, who's the CTO of Photobook, to share about security. We had DevOps by Thiru, who's a partner SA. We had containers by Osama, who's finally a UM student, but also a Kubernetes and containers aficionado. And then we had the CTO of a startup, Vaz.ai, Ashrik, who came and shared about serverless. So we're rounding up this whole session and with security because at AWS, we believe security is job zero. Anything you start with has to start with security. So it's a good way to round off the whole discussion so that when we jump into future sessions, we'll actually start incorporating security as a layer across whatever we build in terms of applications. Now, for folks who would start missing us from next Friday, don't fret. We have a Twitch channel available by the AWS DevX group. So AWS DevX group is actually a developer accelerated developer experience group within AWS that works on building content for you. And this is content that deep dives on different services and how to build applications on AWS. So it's kind of like a place where you as a builder can learn how to build on AWS. So there's a lot of topics being shared over there. It's been happening around the same time this started. I believe it was a little older. It started in April. There's a lot of content available on the Twitch channel, especially if someone's looking for localized content in their language. So right now we have language in Bahasa Indonesia, we have it in Vietnamese, we have it in Thai. We don't have anything in Bahasa Melayu yet. But if anyone's interested to partner with us and deliver on that content, I mean, totally we're for it. So if you want to know more about that, do check out our Twitch channel on DevX Connect. We have sessions every week happening over here, and we have a lot of guests within AWS who come in and then share about how to build on AWS. So that's kind of like where you would want to get started. So with that, I'll jump into the talk directly. So Omar, you can stay backstage, and then we'll bring you in once we're done. Yeah. Cool. See you. All right. So let's go ahead and then let's start from the beginning a bit again. I think I covered some of this in our serverless talk last time, and the whole concept of serverless comes from this notion that as a developer or as a builder, you want to be able to build applications yourself. And when you're focusing on the code, when you're focusing on writing business logic, the last thing you need to be thinking about is infrastructure. And Werner Vogels, who's the CTO for Amazon.com, said this in one of the reinvents where he said, no server is easier to manage than no server, right? So the idea that the fact that you don't have to even think about the server when you're building applications makes it a much more powerful paradigm to work with. And if you take this and then stretch this to serverless in general, there are three dimensions on which serverless can work on the cloud, especially on the AWS cloud. So one is on compute. So the idea is that you don't have to manage a server where you're hosting your application. The other one is on databases, where you don't have to manage a database server and you don't have to scale it, so that the service which you're using scales it for you. And the third, the serverless, would be in storage, where again the storage size can scale to as many files you need, and it can also scale to the number of requests that are hitting it, so that it can serve the files out. So in all three, you'll notice that there is no infrastructure you need to manage. In our case today, we will be focusing a bit on serverless computing, because a lot of the brunt of serverless, when people think about it, comes from the compute perspective. And just to set the record straight, all of us have being on the same page. Serverless computing is actually a way to build and run applications without thinking about servers, right? So you don't have to provision, scale, or even manage any of the servers. You just build for any type of application or backend service, and everything that is required to run and scale your application is handled for you, right, by the provider. So in this case, it's by the AWS cloud. And if you then see it across other places, one thing is that apart from infrastructure not being managed, you also get automatic scaling out of the box. You pay for value. So literally, the pay-as-you-go model, which we spoke about the cloud across different topics since July, comes to fruition in serverless. The fact that if you, like, for example, if you use one of our services like AWS Lambda, which is purely serverless, you just write code and you give it code. You only get charged if a request is, if a Lambda is invoked, right? If a request is actually handled. If there is no request coming in for that specific Lambda, the Lambda will just sit over there. I mean, the code just sits over there. So you're basically paying for nothing to keep your code. And only when maybe once in a blue moon it gets executed, that's when you pay for it. So that literally takes pay-as-you-go model to the extremes. And you're also talking about it being highly available and secure. The fact that you don't have to worry about provisioning servers means that anytime you invoke a function, you're sure that after a certain amount of time, like the initialization and all that stuff, your request will be handled by a Lambda, right? Or by a serverless service in this matter. So in this case, AWS Lambda or anything else. And serverless is an operational model that spans many different categories. Like I mentioned, there are three dimensions you would look at from services. So one is compute, one is data stores or basically databases, and storage is what we saw. There's one more layer, basically integration. And in this case, integration comes from the aspect that in the old days, we used to build a lot of classic applications. We used to have a lot of integrations between services, and for that we would use something known as a middleware. A middleware's job would just be to sit and maybe route messages across, do some massaging of data, transformations of data, do transformations between protocols also if needed. So I used to work in the telco space in the starting of my career. I used to lead a product team that used to build applications for telcos to translate between different protocols, and we used to build a middleware for that. So that's kind of like the way you would want to look at integration in this case. So if you take it on the cloud, what happens is then you get APIs, right? So you get an API gateway. In this case, you would have queues, you would have notification systems, and then orchestration services. Like let's say you split your code across multiple Lambdas, you need a way to orchestrate all of this. You could use something like step functions or simple workflow, which is the older one. And then AppSync, which is basically a wrapper around multiple serverless services in AWS, so that you can then just focus on building application code, and you don't have to worry about the database. You don't have to worry about how to host your code. It's a very opinionated way, and it manages a lot of that along with the APIs. So a lot of things with that. Amplify and AppSync is something we want to cover in a future session. So definitely look out for that. So if you start with serverless, and a lot of folks, when they start with it, they just keep it very simple, right? So it starts with a very simple pattern, very straightforward API, which is put a RESTful API. So you put an API on API gateway, and then that API gateway would then invoke a Lambda, and then that Lambda just talks to a database, right? So you're just talking about a very basic CRUD API, and that's being accessed by maybe a mobile application or a web application. So straightforward, up and down. I mean, there's no fancy stuff in the middle. It's basically synchronous in this case. If you notice that only when a request comes in, then the response is sent back, and that response is tied to the request that comes in. Now you can start scaling this pattern, because there will be different forms of operations you want to do. And when you move into, let's say, a microservices environment, so in this case, let's say you have clients, it could be like a mobile app or a web app or even other services internally in your application, right? So you have other services talking to services. So in this case, you could still take the same API gateway and Lambda, but you could have multiple Lambdas being invoked as part of the requests that are coming in. And then you could have some Lambdas talking to a database like Dynamo. You have another that is talking to a storage service like S3. And then you have some that is talking to a cache like Elasticache, which is also a almost managed cache service by AWS. So it uses Redis under the hood or Memcache, depending on which option you choose. So that's one way it will start scaling. Now, if you notice in some of this that there is still some infrastructure that's there, right? Because what you're doing is that you are still invoking some stuff that is that still requires a server somewhere or the other. Like in this case, with Lambda, if you like, for example, if you don't want to go fully serverless and you still need to go hybrid because you have an application that is already sitting for quite some time, like an EC2 instance, a virtual machine that is hosting an application, you would then have a database like maybe RDS, which is a relational database, which you saw in one of our database sessions. And what you want to do is you want to still have serverless compute functions running on a serverless compute platform, but invoking a relational database. So the database is not fully serverless because it's basically running in your account. So you'll have to still manage some part of the operations in that. But most of it is handled by AWS. But in that end, infrastructure is still there. So what you would do is you would have to create a VPC. You would have to ensure that they're all within the same network and then execute this. But in the meanwhile, your web application could still be serverless because you're using a distribution network like a CDN called CloudFront, which then hosts your application and any files that are recently being accessed in a point of presence locally to your location or to your user's location. So in this way, you could still continue with the same serverless pattern and have some infrastructure required as and when it's needed. Then you can start looking at scaling further, because Lambda scales to a certain level. If you want to scale further than that, you would start looking at maybe containers, for example. And you will notice that you want to add more services in which you don't want to code yourself. So in this case, instead of you building your own authentication mechanism or authentication backend, you would use something like Cognito, which allows you to handle authentication under the hood. You have that. Then you have security token service that's useful for tokens, and you would use that as part of the authentication flow. So you have user identity management happening over here, and you still have core business logic going through in this case. Now, you could replace this. Now, the thing is, when you have an infrastructure like this, it makes it super easy for you to replace, especially if it is serverless, because if you have code running in Lambda and you want to scale it further, you want like maybe because a Lambda's soft limit is when you execute a Lambda within your account, you can have only 1,000 Lambdas concurrently executing within a region in your account. And the thing is, you want to scale further. Let's say, for example, so the way you would do that is you would switch to containers. So you could still take that same code, plonk in a container, but everything else remains the same. And that's the whole beauty of this whole solution. The fact that you can just swap in and out whatever services. Like in the old days, we used to always talk about plug and play peripherals, things which you could just plug into the PC, and then you have these generic drivers that would work to manage those that peripherals. You're talking about generic services, right, over here. So you have application code that can reside at different compute platforms, and still everything around it works. Because what you would have done when you keep building this architecture is that you would create very clear interfaces between all these services, right? The services which are already managed by AWS have pretty clear interfaces. When you write code also, you'll ensure that you're invoking only on those APIs which the services have. So it makes it super easy to just swap in and swap out your compute platform. So when you take this whole thing into consideration with the way that how serverless as a platform and as a pattern in your architecture, when it evolves, you'll see that there are common security approaches you'll start looking at. So in serverless and containers, they share a common pattern, especially if you start looking at breaking down your code. So it's basically microservices, and your core business logic can be modeled as code or containers. So if you keep it as code, it will be a Lambda. If you put it as containers, it would be like maybe you hosted on one of the container services, which we saw a bit when Osama spoke about it early. I believe it was in August or September. And in this, what you do is you can also reuse the same thought model for both serverless and containers, because they kind of share a very similar paradigm. So if we jump into security or serverless and containers, you'll notice that from a security domain perspective, this is basically how you would start looking at, from whether you go across the spectrum of how much infrastructure is required and how much infrastructure you need to manage. So if you take it from a compute and data perspective, this is what it'll look like. If you take from a communications perspective, this is what it'll look like. So if you're starting out in the serverless world, you may not even go towards infrastructure. You wouldn't even look at containers in the first place. You'll start looking at just building out lambdas. You may use Fargate as a way to just step into containers, because in Fargate you just supplied a container and then the infrastructure under the hood is managed for you. Then you would have APIs of your own, and then you would have step functions over here. With data, it's the same thing. If you're not managing a server of your own, these are the options you would get. You could get a NoSQL database. You could also look at Aurora Serverless as an option, which the icon's not here, but still makes sense from a serverless perspective. From a communications perspective, when you're having integrations between multiple services, you could look at SNS or Kinesis. And then if you're having it within a network, you want to block the network, you would create something like a VPC. So that's the security domains. Now, you take all of this, you still have one more element called the edge, which is where your applications would deliver on the last mile, right, towards your users. And this is where CloudFront comes in. And CloudFront is literally like, it's all managed by AWS. You don't even have to worry about it. Even though the infra is there, you are just deciding on which distribution you want to create and how you want it connected. There is infra there, but you don't have to manage it. So it kind of like sits in the middle, if you can call it like that. Then when you add management, access management and identity, you're talking about using something like Cognito for authentication, and then using IAM for the user roles and the user accounts within AWS, right? So Cognito is for users to your applications, and IAM is for users on AWS to access your AWS services. And then you would then have systems monitoring and deployment. So when you put an application and you're going into production, you wouldn't just deploy it and then forget about it and I hope everything works. What you would do is you would continuously monitor that application. So you want to make sure that you're able to access all the application logs, and you're able to access all the access logs of AWS, right? Who is accessing your AWS account, and and you can audit it anytime you want, right? Just to make sure that it's always secure. And then you would look at trying to jump further into your application, try to understand how the application works. You would use something like X-ray. We'll touch on that in a bit, depending on whether we reach till there or not. So from a security perspective, when you notice, there are 4 levels to security. I mean, it's a phase basically, and this usually comes in when you are when you are handling the SIEM part of things, like security integration and something. The idea is that you are ensuring that the whole security workflow of your infrastructure is managed. So SIEM software allows you to do that. So in SIEM, whenever you're in the SIEM world, they talk about these 4 steps. So you have a directive, you have preventive, detective, and then responsive. So a directive is basically like a straightforward, like a block kind of a thing, which you're saying, okay, who is allowed to use XYZ, who is not allowed to use XYZ. So this is where authentication and authorization comes into the picture. And this establishes controls. With directive, it establishes controls for governance and risk, and any compliance model the environment will operate within. So think of policies, think of the way that you at a high level you're just saying, this is what my account and the behavior of the users is going to be like. The next step is preventive, and in preventive it is you're basically controlling and protecting your workloads to mitigate threats and vulnerabilities. And this is usually a lot of times it is about anomaly detection, checking out user behavior, understanding whether the behavior which you're seeing on your account or your application is normal or not. So you have a lot of services available for this. We have been doing, in fact, today AWS Malaysia, we did a webinar for guard duty, and guard duty, and it's not here over here, but guard duty over here, and we did our security hub, which allows you to actually detect threats in real time. So similar to that, you have WAF, and then you have Shield and Secrets Manager. So with WAF, it's a web application firewall that allows you to configure rules and then plug that into any entry point which you are having on your applications. Like for example, API gateway, or you could do it on CloudFront, or you could do it on a load balancer which you're having. So what it'll do is, based on the rules, it will check whether this request is valid or not, and if it isn't, then it will based on how you configure the rule, it will do a certain action for you. So SQL injection attacks, for example. A lot of times when people do applications like even PHP, they will be using a MySQL database, and they wouldn't secure or sanitize the requests that are coming in. So someone can just fire a SQL request, as a SQL query as part of the request itself. So things like that you can configure in WAF if needed. Shield is another one that allows you to mitigate DDoS attacks. And then you have Secrets Manager that allows you to automate and have policies around rotation of secrets, manage secrets with, and here it's like an application talking to a database. You would usually provide that hard code the credentials of the database in your application code, which is an anti-pattern. You shouldn't be doing that. So you would use a vault service. So Secrets Manager is basically a vault service that allows another service to manage all the secrets for you, so that only authorized services can access that vault, right? So that's how you would do it. Now with Detective, it's basically controls that provide full visibility and transparency over the operation of your deployment. So think of monitoring, think of logging. In this case, you have CloudWatch, which is application logging. And then you have CloudTrail, that is like all the usage of AWS accounts and services at a AWS user level. And then you have a trusted advisor that allows you to detect any usage patterns and then suggest what you can do about it. Whether there are some security checks, a lot of it is cost optimization checks also. Guard Duty allows you to enables you to scan for vulnerabilities that are happening and maybe any attacks based on logs which come in CloudTrail, VPC flow logs, or anything else. So you can just point it to the logs, and then it detects based on underlying algorithms. So it runs an ML model separately, and then it also does anomaly detection. Security Hub is a place where all of this can get plugged in. So Security Hub will actually plug into multiple services like Guard Duty, WAF, and all, and then bring you one consolidated dashboard. This is basically, if you're in the SIEM world, as I mentioned earlier, the SIEM world will have one massive dashboard that can allow you to check the pulse and the health of all your systems throughout the day. So think of Security Hub or something like that. Then you have the responsive part, which is basically it drives remediation, right? So now you found out there's a problem. You want to handle it in some form. So you want to automate some of that handling, right? Remediation. So in this case, what you could do is, like, to give you an example, if Guard Duty finds out that an EC2 instance is being a port scan is happening on an EC2 instance, you could trigger a rule in Guard Duty to actually trigger a Lambda. And what that Lambda could do is that it would then execute maybe a policy, or maybe bring down that EC2 instance if it sees that it's not production instance, or maybe take a snapshot of the file system and the image to see what exactly has happened before someone deletes the file system. So a lot of remediation. You can also use CloudWatch alarms, which could then send you SMSs through SNS or an email to get alerted that, okay, there's something happening in the system. Similarly with application tracers in this case. So let's dive a little deeper into the compute layer. So with compute, if you're looking at code or containers, you're going to come across these 4 services on AWS. So Lambda is basically a serverless event-driven code execution platform. It's short-lived, so it's just like you invoke it, it executes. Once it's done, it stops itself, right? So it has almost all language runtimes available. You can customize some of that right now. And data source integrations. We usually call Lambda as the glue between a lot of services, because you can trigger. You can get a trigger from one service and then trigger something else along the way in Lambda. Then Fargate is basically a serverless compute engine for containers. And this is where you can supply a container to Fargate, and then Fargate manages all the underlying infrastructure to host that container. And it's long running. You can bring your existing code, which is basically a container, and it's fully managed and orchestrated for you. ECS and EKS is where you start taking the control in your hands. So with ECS, it's basically our own homegrown orchestration service. It's Docker based. Then if you're coming from the Kubernetes world, then you could use something like EKS, which is basically Elastic Container Service for Kubernetes. Almost, I mean, it has all parity with I believe we are always one version behind the latest master branch, but we always update it once it comes, because we always test everything from the master branch in Kubernetes to make sure it runs properly, and then we deploy it in. So you'll always see this. We are behind one version. Now, from a comparison perspective, when you see it from an operational responsibility perspective, if you go from if you want more control, you would actually go towards less opinionated, because you have a certain way you want to handle the infrastructure. That's where you would start going to managing your own servers. But the more opinionated it goes, the more you're expecting AWS to manage it for you, and you're okay with it, right? So if you go up or down this stack, you will see that, okay, hey, you know what? With Lambdas, it's like the customer only gives code, which is super awesome if you're just a developer who wants to build something quickly. You don't want to worry about the artificial heavy lifting. If you want some more control over the infra, then you would look at maybe managing it through containers. You would get data source integration, security configs and updates. If you want more control and you don't want to give it to Fargate, then yes, you can run your own ECS and EKS cluster over here. And then, of course, EC2 instance, a standard VM in this case, where you can run an application code and scaling. So if you notice, the whole idea of talking about security and this is that to give you an idea of where are the different attack vectors from which you have to focus on from a security perspective, right? Because the moment you give everything to the cloud provider, you're expecting the cloud provider to manage all of the service for you, right? In Lambda, for example, all you need to do is provide the code, everything else is handled for you in AWS's case, right? So when you go into compute layer and security in the compute layer, you'll notice that, if you take it across 3 dimensions over here, you have input validation. So for example, any request that comes into your code, you want to validate the input of that. So this is where WAF can come in. Like I mentioned, you can configure rules for things like XSS site scripting, and then SQL injection. This is for cross-site scripting, and then this is for SQL injection to ensure that your requests are all sanitized. Then you have API gateway requests. You can also validate the request in this case, so you can ensure, okay, there's a payload, there's not a payload, is this the type of payload that's supposed to come in or not. Then at a code container perspective, this is where the onus comes on the developer, where you sanitize the input in the code. Definitely as a developer, you don't expect to be building an application and not sanitizing your input, right? You would do that even if you're doing it on localhost. And if you're not, then we should be having a different conversation altogether. So that's basically on input validation. So some of this you will have to do some form of validation, but a lot of it the brunt of it can be handled by services like WAF and even API gateway. The next step is, okay, what about dependency vulnerabilities? Because we live in a world right now where you don't build everything from scratch, right? There are a lot of libraries available. And if you come from the time where I come from, right, in Java, when I started with Java, we used to have libraries, like core libraries, but the rest of it, we used to build it ourselves. But then come Node.js and JavaScript, it's like everyone has a library for everything. If anyone remembers about there was an issue, I believe it was 2 years or 3 years ago, where one of the open source contributors actually revoked his package from open source because of some issues I believe he had. And the library only it used to do a left shift of a bit. And surprisingly, a left shift of a bit is something you can just write. It's just like 1 or 2 lines of code, and you can add it in your own code. But there were a lot of key libraries which everyone was using. A common one called Lodash, right? Lodash has a lot of utilities hidden inside. As a service, it provides a lot of utility functions which you can invoke to manipulate strings and do other things on basic output. And Lodash was using this library, which just does a left shift of a bit. And the moment that got revoked, it broke that package. And because Lodash is used in a lot of other packages, it broke a lot of other packages. So you had this cascading effect. So that is just and the person who did it, he did not have any malicious intent. He just did it for other reasons. But let's say you are actually using libraries, and a lot of your developers, or even yourself, you must be taking a library from GitHub because you think it solves a problem. How do you know that dependency is not vulnerable, right? So in this case, you want to, as much as possible, have vulnerability checks happening on dependencies also. And what you could do is, in a code container perspective, and there is one part even about when you do, let's say, automatic builds, you can actually look at it later, which I'll show you towards the end. So with code and containers, you would want to minimize dependencies, right? As much as possible. Use a library. It makes your work faster and life faster. But very simple libraries which just do a left shift of a bit. Come on, seriously, you can build that yourself in 2 minutes, right? So you should always use only the required dependencies. Don't bring in dependencies that you don't know, and also don't bring in dependencies from unknown sources, right? Another step is you would want to set dependency check tools available. So there are a lot of tooling available. You can have a look at this list also out there. and they will always update the lists of especially vulnerabilities in common and popular packages. Another step you can go with is also Lambda layers, because with Lambda layers, what happens is that you could vet a certain set of dependencies and then put it in a Lambda layer, and then share that across multiple Lambda services, right? So think of Lambda layers as just a common library, which is a common set of libraries that you're putting in, inserting it when a Lambda executes. So when it executes, it load that layer also as part of the execution runtime. And you can also do a lot of this dependency checking when you build the code. So we'll get to that towards the end. Then you have secrets. Now, again, I mean, like as a developer, I want to make sure that I'm writing code fast. I'm building applications faster, right? I mean, I have a lot of requirements. I have a deadline. And you usually will tend to just write hard code secrets, right? Maybe you're calling a third-party API. There's an access key. You'll hard code that in your configuration file. You're talking to a database. You'll hard code the IP address and even the database credentials within the file. So you would want to start looking at moving away from that model, because you want to, as much as possible, store that somewhere. So even if, let's say, somebody malicious, someone gets access to your account in some form or the other, or maybe if you're hard coding it and you're storing that in your code repo, for example, you want to make sure your code repo is clean and safe, so nobody gets any access keys, right? So this is where you would use a vault-like service. So Secrets Manager is an option which allows you to build a password policies, so you can always rotate policies, because what's worse than not having not storing a password separately is not rotating the password. And if you don't rotate your password, it basically means that anyone who's working with you can take that password later, and they'll still know, hey, this person is not going to change the password, so let me just give it a shot and let me try to access this database somewhere. You don't want to do that. As much as possible, you want to rotate password policies. We rotate our passwords on a lot of services already, right, when we use any SaaS service. So you would want to do that for your application also. So that's Secrets Manager. Parameter Store also allows you to do that, but Parameter Store doesn't have rotation policies as part of the service, but it is useful when you want to have key value pairs more easily than Secrets Manager. Then there's another option where Lambda allows you to have encrypted environment variables. So when you load a Lambda, there are environment variables you can load as part of the runtime, and Lambda will then refer to that through the code directly. So you could encrypt that and then put that as part of the Lambda. So that's the lowest level, but always I would suggest to go with either Secrets Manager or Systems Manager Parameter Store when you're storing secrets in your application. And why Secrets Manager, right? I mean, because you store secrets, you can also store database credentials, passwords, third-party API keys. It has a reliable secret rotation mechanism. There's no service outage also on this. A maximum secret length is 7 KB, and it has integration with other services. So what you could do is, if you're using a database in RDS, you can directly store the RDS password in Secrets Manager. So your Lambda just needs to invoke your Secrets Manager for, hey, I want to talk to this database. Okay, if you are authorized to do this, I'll give you the password, which is pretty cool. So this is how you would choose between the two. Like I said, there's no rotation as part of a parameter store, but you have it as part of Secrets Manager in this case. With Lambda layers, it allows you to function, share code, upload the layer once, reference it anywhere. It promotes separation of responsibilities, so your libraries are not always part of the code delivery you're doing. And you can also share it with the ecosystem. So think about it, when you're having multiple developers who are building code, you want to make sure that they all use the same version of the library, for example, right? Or library which you have tested and you know that it's secure. So you would just tell everybody else, hey, just use this layer, and they can immediately start using it directly. So what about insecure code, right? Let's say, for example, all of this you've taken care of, but what if your code itself is insecure? Maybe you write code which is insecure, or for some reason someone's written malicious code, right? And they want to do certain things that you don't want them to do. So Lambda's execution environment, so this is where it goes into how Lambdas even execute, right? You need to understand how it works so that you can understand the whole security aspect of using serverless in the first place. So when you invoke a Lambda, what Lambda does is it creates something known as a data plane, right? And this data plane will have all the function code. It will have the Lambda layers, any dependencies. It will have the runtime for the code, and it'll have a minimum Linux userland that's based on Amazon Linux, which is our version of Linux. And this execution environment is never shared across functions, and micro VM. So it's never shared across anything, right? It resides only within your account, and it will only reside within that function, for that function which you have allocated it to. So if you see in this diagram, what happens is that this is basically in an AWS account boundary. This is the Lambda function boundary. So your function code only resides here. This is the effect and impact it's only going to have. It's not going to go beyond anything else, right? So this is basically your impact. So think of this as one Lambda. Think of this as another Lambda. This cannot have access to this Lambda unless it uses the standard interface of invoking another Lambda, which is basically through the APIs using the AWS SDK. So this is basically the level of security you're looking at when you're executing on Lambda. Now, if you move towards micro VMs, for example, micro VM is actually think of it something as between containers and VMs, right? So in a virtual machine, you actually get a host operating system, and then you will have each virtual machine having its own guest operating system, right? And then in a container, you actually just have the host operating system, and then you have the container runtime. This is in the middle, where you have a micro VM in the middle, and this micro VM will actually allow you to run multiple, similar to like Lambda. It will allow you to run function code, runtime, and execution environment, and it won't allow you to transcend any certain boundaries. In this case, we also released a micro VM called Firecracker, which is available open source, so you can also try looking at it yourself. And this allows you to also run under Firecracker. You can run a separate micro VM, so you can isolate it even at a micro VM level. So each function which you execute can actually execute in its own micro VM. So you're talking about total isolation. It also allows you to isolate the host OS directly from all of this, so it keeps it like clean. The boundaries are pretty clean in this case. So from a design consideration, when you look at Lambdas, when you invoke a Lambda for the first time, what happens is it requires to bootstrap, because it needs to load all of those things like the runtime. It needs to load the libraries, the dependencies, and the function code, and even that basic user land of Amazon Linux, right? So that adds some latency. So the first time you invoke a Lambda, that specific Lambda, it'll take some time to load it, but that's only one time. The execution environments can be reused by subsequent invocations, right? So the next time you send the next request immediately. So say you're actually reading the list of let's say you're reading a list of buildings in KL. So the first time you execute, it'll take some time to load the Lambda, initialize it and all. The next time you send again a list, it's going to reuse that same execution environment, right? Until there's a cooldown period, until which it sees, okay, there's no request coming in, and then it'll retire that whole execution environment. And this execution environment includes a writable file system. So you will actually get something like a temp folder, which you can write to if you need to share something between requests, right? As long as that execution environment is still available. So Lambda provides also patching and updates for supported runtimes. Maintenance of custom runtimes is customer responsibility. So with Lambda, you get some runtimes out of the box, which is managed by AWS directly. But if you're running a custom runtime yourself, which you can do, you have to manage the whole update and patching of that runtime yourself. So it's your responsibility. AWS just provides at a high level how you can actually execute that custom runtime. So with a best practice, when you start looking at, okay, now you've seen all the way the execution environments work, you've seen how you can load data inside Lambdas. What you would want to do as a best practice, because you want to minimize cold starts. We call this as a cold start problem, right? So if you want to optimize a micro VM reuse, you minimize the packet size to the necessities, so that way it doesn't load more things that are required. Then this part is actually changed a bit right now. So it's become better. ENI is actually have become faster now attaching ENI. So this is basically attaching a network interface. This is useful when you have a Lambda that is tied to a VPC, right? Then you want to instantiate AWS clients and database clients outside the scope of the Lambda handler. So in this case, for example, when you execute during a cold start, and if this is your code, if you move this connection outside of the handler, it will then ensure that it is initiated when the Lambda runtime is started, and then the runtime will keep that connection up, so that you can then do the next invoke, and it doesn't have to re-instantiate a connection to your database, for example. So as much as possible, avoid code to read or write to temp if it's not needed. But this is useful if you want to just share a certain resource across the requests, but try to minimize that. And then as much as possible, if you leverage the AWS supported runtimes, then you're in good hands, because it's been optimized for Lambdas directly. And this also supports the whole security maxim, right? The idea is that hey, you know what, AWS has vetted this runtime, so I don't have to worry about the security aspects of my code, right? Where it is running or the environment where it's running. When you go to ECS and Fargate, what happens is with ECS, for example, you manage the EC2 instance and you manage the operating system, the Docker agent, ECS engine. I mean, most of this is handled by AWS, but it still runs within your account. So you'll see that the EC2 instances are running in your account. But with Fargate, what happens is the EC2 instances are not in your account. All you have in your account is the task definitions, and then everything else is run outside of, it's run at a central regional level, which basically means it's fully managed. Now, with ECS and Fargate, this is how it works. So in networking, ECS uses ENI within your account directly. With Fargate, because it's outside of your account, you're basically looking at using AWS VPC. You are then having granular ECS service roles and tasks, which is similar in Fargate. And then provisioning, patching, and scaling is with the customer. In Fargate, it's all patched by AWS. So you don't, because you don't have direct access to the underlying infra at all. It's only with AWS, and the privileged access is forbidden. Basically, in ECS, you can SSH into the host machine if you want to. Right. So that comes from a whole compute layer, right? So now let's say if you go to the data layer, where you're actually having data coming in, right? Databases, and then you're storing files and all that. From a data classification perspective, the kind of data that's coming in, you could use a service like Macy that has been trained using machine learning models to detect anomalies in certain types of data. If you're looking at data flow, which is basically application traces over here, you would then look at X-ray that allows you to monitor applications when they're executing, and then suggest to you, okay, from a timing perspective, which service is faster, which service is slower, which line of code is actually faster or slower. So you can do something known as recording as part of the code execution. Then you can look at data tokenization. So you could do this yourself. So you can tokenize your data. If you're doing salting and hashing, like for example, encrypting it at your end, you can do it yourself. Or you could look at marketplace solutions that are available already. Now, data encryption, when you talk about it from a cloud perspective, you usually will talk about encryption at rest, where when data is stationary in a certain service or a certain place, and then when it is being transmitted to another destination, right, from source to destination. So with destination at rest, you're basically talking about encrypting the data directly. So you would use a key management service. So in AWS, you have a key management service, which allows you to do server-side encryption of basically where the data resides, and then you would then create a client-side key, which then a client, when they access the data, they will use the client key to decrypt the data so that they can read it, but only an authorized person can read it, right? So this is for encryption at rest. The moment you want to do encryption in transit, then you're looking at something like SSL certs, right? So in this case, in API gateway, you'll make sure that it's always HTTPS. And you can also provide your own certificates. So you could use a service like Certificate Manager and manage all your SSL certs for any kind of custom domain in this case. If you're managing a production application right now, and it's not having SSL certs, please go and just get a free cert on Let's Encrypt and then just use it on one of your services. If you're on AWS, just go ahead and get a Let's Encrypt certificate and then upload it to Certificate Manager and then use it in your services. Do not use your production grade applications on HTTP. Even your browser will warn you. So take that as a suggestion and advice, and very strong advice. So please do use SSL certs for your applications. Now, when you go with backup and replication of data, there are different layers of security you can look at, right? So the first one is versioning. So when you store data, if you're deleting the data or if you are always updating the data, you want to make sure that you have previous versions of the data available. S3 supports a concept called versioning. So if you enable it, you can then look at, okay, different snapshots of the data of the file being changed always, because S3 is basically an immutable data store. The moment you upload a file, the next time you upload another file, it's actually replaced totally. All right, so it's not like edited and then you make another change inside. MFA delete is another one. So this is basically for multi-factor authentication delete. Then you can also do cross-region replication. So with S3, you get multi-AZ replication out of the box as a default mode. There's another mode that allows you to just store in a single availability zone. However, if you want to take more extra precaution and you want to make that data available in, let's say, in another region for reasons like maybe you're doing a disaster recovery setup where you want to spin up another instance or another set of services in another region, then you could look at cross-region replication where all your data in S3 is then replicated at the same time, nearly same time in another region. Then with the database, if you're using like a NoSQL database like DynamoDB, you will always look at backups, of course, and you would also look at you could leverage a service a feature called point-in-time restore that allows you to restore DynamoDB to a certain point in time. So this is kind of similar to how in Windows from many years we have this option where you can restore Windows to a certain point in time before you install a certain application. Very useful when you want to troubleshoot, okay, something's wrong with my machine, I think I installed something that has messed up maybe some of my settings. So think of it like that with the data itself. Then you have something known as change streams that basically allows you to trigger workflows from DynamoDB. So any updates that happen on the records, it will actually trigger, you could trigger a Lambda, and then it will take that object that record that has been updated, and then you can do something with it. So think of this as if you are in the SQL world and you have run managed SQL databases and used stored procedures or even tables, you would notice that they have triggers on tables. So you would have a post trigger. A post trigger, pre-trigger is basically before an insert or update or a delete is done on a record, do this action. So you'll write some code for it in T-SQL or transactional SQL or something. And if once the operation is done, then you do a post trigger. So after the operation, you would actually invoke something and then run that. So think of change streams like that, but it's mostly for the post part. It's not for the pre part. RDS, again, with the data backup replication, you have automated backups available as an option. You can just enable that on RDS directly. Beyond that, you're also looking at security in the access management and identity layer. So API Gateway, for example, has authentication as an option available. So you could use IAM directly, AWS Identity Authorization Management Service. Then you can use something known as a Lambda custom authorizer. So you write a Lambda code that would then authenticate and authorize for API Gateway. So you could write custom code inside, right? You want to just do basic email and password. Well, it's up to you. You can just write that code inside, or it has to talk to a third-party API. You could do that. You can also look at Cognito's user pool. So Cognito allows you to create all these pools, user pools, and then do this. And also it allows you to create user directory or federation with other directory providers or even other social media, social login providers, right? Like Google or Facebook. You could create those identities over here and then map it. You can also look at creating standard JWT tokens or AWS credentials. With IAM, like I mentioned, this is for access on AWS. So you would identify IAM principles, you would have least privileges, and then enforce boundaries across. So this is basically about who can access what service or resource on AWS. Very powerful. Very important, and it's one of the basic forms of security you can do on AWS. So do keep that in mind when you're actually looking at securing your AWS account. So once you move from authentication and then you're going into systems monitoring, you're monitoring all your services. You would look at logging and tracing. You would look at with API Gateway, you get a lot of logs. So all your services which you use on AWS, especially if you're managed, you would definitely get insights and logs of some sort. API Gateway has some logs, access logs and execution logs. Lambda has CloudWatch logs that go directly to CloudWatch. And then you have X-Ray that allows you to do tracing. Then you have metrics also available that allow you to monitor performance of the services. With API Gateway, you have built-in and detailed CloudWatch metrics. With Lambda also you have built-in and then custom CloudWatch metrics and other metrics also. And you can also pipe into third-party tools if you're using Datadog, Splunk, or even like Elasticsearch, for example. Then you have compliance, right? Now, compliance validation is interesting because a lot of times system monitoring isn't about just going and seeing when the issue happens. You want to keep something running behind the scenes so that you know, okay, like maybe you've gone over budget. Or for example, from a security perspective, someone gets access to your machine or maybe to your account and then is spinning up a lot of machines and services and resources. So you want to set up something like budgets and CloudWatch events and even AWS config to make sure that there is detection happening under the hood, and anytime something happens, you get alerted, right? Okay, maybe you're not supposed to move more than $10 in a day, but suddenly you see that $50 is being used, something's wrong, so it'll throw an alert. You can set up a budget in AWS budgets for that. So I won't dive, we have X-Ray. I won't dive super deep into this. Basically, this allows you to debug issues quickly. You can also have end-to-end views of individual services. And basically, the way it looks like is something like this. I'll go to the next one. So X-Ray view, like for example, if you have services running, like microservices in Lambda, without much out of the box. Or if you're using like Elastic Beanstalk or some other service, you can enable X-ray tracing, and what it'll do is it will then check, okay, at a basic level, it'll check, okay, which services are being invoked from where, which database, and which resource like SNS, and then it'll show you how much time it takes, what's the maximum time it took, what's the fastest time it took, so that you can start looking at bottlenecks, right? And you could then look at a trace example. So you can get basic application logs, which you can then drill down yourself. And you can also do recording, like I mentioned, where you can then test at every code level how much time it's actually taking. So each function, each line of code, maybe a block of a code, you can actually test how this application functions. Now, more or less towards the end, right? All of this makes sense from a security perspective when you as a developer are handling this from the code perspective, or even from the infrastructure perspective and monitoring sides of things, right? But when you start automating your infrastructure, you start looking at things like deployment strategies. You'll start looking at, okay, now I have multiple developers contributing to the code. How do I make sure that my application is secure? How do I make sure that the dependencies are secure? So as part of the whole CI/CD pipeline, what you'll be doing is, so if you look at the CI/CD pipeline, which is continuous integration, continuous deployment and delivery, you would look at from the source code onwards. So you have source code where you commit your code. So in our case, you have maybe code commit, or maybe you have GitHub or Bitbucket or something else. Then you build the code in a service. So you have code build, for example, or you could use Jenkins or anything else you're using. I think the flavor right now, a lot of folks are looking at is drone and some other services. Then after that, you would look at testing your services. So you would write test automation code within, if you're practicing TDD and anything else. And once that code is tested, so you've tested only the application logic of the code, that's when then you would look at deploying the code and then monitoring your application, right? And then you would have an orchestration across this whole pipeline, which is where you would use a service like Code Pipeline, where you can code all of this out and do the orchestration of the deployment. Now, how can we actually ensure security in this deployment right now? In this case, right? So you have code commit, you have the source code which is being picked up, and then you are actually pre-creating it. One option is that you can actually have lambdas sitting in the middle as part of every step, so that it can do certain checks on its own before it runs any changes on the infrastructure or on your code. You could also have manual approval as part of Code Pipeline, right? So you could actually do something like, okay, so there is somebody in your security team, or maybe your manager or your CTO, or even yourself for that matter, right? If you have a Code Pipeline, you want to make sure that you do the manual approval. So you can set up a gateway in Code Pipeline, which will send you an email, and only if you click on the link, it will allow you to go to the next step, or else it won't, right? So things like that. So with Code Pipeline, this is how it's going to look like. You would, if you do delivery, it would you would commit your code, then package and test it in code build, then run CloudFormation actions, and then test your application and increase control severity. Now the thing is, over here with CI/CD, what happens is a lot of just orchestrating your infrastructure goes away, right? Because you're automating a lot of the steps which you would manually do yourself, and also what you're solving through this is that you are ensuring that the same steps are executed always. So you're not always at the mercy of, there's only one person who knows how to deploy this thing, or there's only this kind of a way I can just do it. So once you're codified, you're like already, your worries are gone, because if anything happens, you could always deploy it using the same pipeline. So you're pretty safe from that angle, because you're already planning ahead and trying to automate your services. Then what you could do is, as part of your application deployment strategy, you could look at something known as canary deployment. So canary deployments is basically where you send, you want to direct a portion of the traffic to a new version, and then you want to monitor stability. So let's say you're rolling out a new feature, but you don't want everyone to use it. So you would say, okay, out of every request that's coming in 10 minutes, 20% of the requests should just go to the new service. Everything else should go to the old service. So you would do like a percentage, like in this case, okay, you have 30% and some percent traffic shift, and you can initiate rollback whenever needed. And when you see that, okay, maybe you fix some bugs and then you deploy it again. If things are working better, then you slowly shift the traffic more and more towards the new service. And then once it's done, then you'll remove it from there. So in this case, you'll notice the traffic shifting status 70% to the old one and 30% to the new one. This is basically a norm or standard of some sorts if you're ever doing any kind of CI/CD. So this is basically how it looks like from a security deployment layer perspective. You would look at version control. So again, who gets access to the code? Then you would look at if you're using a container registry, like if you're using Docker or ECS or EKS, you would then manage your container repositories, and then again ensure that only certain services can access your repository to pull the image down, right? And nobody else has access to it, so that they can push a malicious image in. With code quality, with code pipeline, you can plug it into third-party tools, like what I mentioned last time about the dependency vulnerability checking. You can do that in code pipeline by integrating third-party tools. In this case, so you could plug all of this, which I had listed earlier, in as part of your deployment pipeline, and then it can check what's happening, and then if anything fails in the check, it will then just stop the pipeline, and then you'll just get an alert. That way, you know that okay, you've not deployed anything insecure in your with a dependency perspective in your production environment, right, or in your staging environment or wherever. From a deployment strategy perspective, like I mentioned, I showed you canary. Blue green is basically like is something like you have the old service, you have the new service, and you just switch everyone to the new service, right? So it's green. And the moment you know that things are all right, then you remove the blue service. But if things are not good, instead of rolling back the code, you actually send everyone back to the old service. So that's kind of like how you do blue-green, which is why it's two colors, blue and green. And then you have CloudWatch and X-Ray as a way to continuously monitor your applications and do this. So yeah, I mean, if you're looking at more additional resources in this case, what I would suggest you to have a look is, especially with serverless, try to understand what serverless is all about more, so that it makes it easier for you to understand the paradigm and architect your applications in this way. Look at our security blogs. We have a lot of security content available because, like I said, AWS, we believe security is job zero no matter what. And we also have a list. I mean, there's a third-party list being managed by PureSec. They manage all serverless security related resources over here. A really good place to go and learn more about what third-party services and tooling is available for you to have a look. Also, do read our white papers. We have a lot of established, distinguished engineers and architects who prepare these papers with their experience, and they talk about how you need to think about the cloud, how you need to think about security, and these papers allow you to actually understand that thinking, so that you can then you can build applications more securely and more better. So have a look at the cloud adoption framework if you're starting to move to the cloud. Have a look at the security overview of Lambda, which I touched a bit on over here. Then also look at multi-tier architectures where you're trying to build more complex serverless architectures with API gateway and Lambda. You also have training and certification available. There are some free on-demand courses available on AWS.training. So do go to serverless development, how to get into the serverless mindset, Lambda foundations, and then also API gateway and DynamoDB if you want to use NoSQL. And there's additional paid trainings and digital trainings available on AWS.training. So do have a look at this. But a lot of this basic content will actually help you go a long way in terms of understanding serverless. So yeah, I mean, so with that, I mean, thank you so much, everyone. I mean, this has been a super long journey. I'll just bring the rest of the folks in over here as a way to close the curtains on this whole series. The fact that this has been running since July and we've been running it almost every Friday. It's pretty awesome. There's a question by Ayman about sanitizing the input. Well, so here's the thing, right? When you fire an input request, for example, to an API, you can actually, if you don't secure your application, if you take a very normal application, if you write it right, you can, I'll give you an example. SQL injection actually became popular, especially with PHP, where you can fire a post request. And as part of the post request, let's say you are just doing, you want to find out a name, okay? So what you would do in your code is you're saying, okay, if I get this text, I'll just take the text directly and then attach it in my SQL query, and then I'll fire that query. So maybe behind the scenes in your code, your query is, okay, select this, select star from XYZ, from your table XYZ, where name is equal to maybe John. And you wrote the code expecting that the person who's sending the code is sending the request is always going to send you a name. But me as a malicious person, I can come and say, hey, you know what? Let me try if I can fetch everything out from the database from this guy. So what they can do is they can actually write a delete statement, or maybe a select statement, or maybe a list of all the tables, right? and they can insert that as part of the request. Now, if you don't check your request and sanitize it and see whether, okay, is there a SQL query available in this request, then you wouldn't know whether somebody has actually attached a SQL query in the request, and then you have executed it without you knowing, and they get details about your database. This is how a lot of the old ways of getting data out of your database used to work. So when you sanitize the input, what happens is you may use a library, or you yourself can check if this request that's coming in, if it looks like a SQL query. So you would use something like a regex expression, right? Regular expression, where you could write, okay, if it's a SQL query, it'll look like something like this. Or maybe you'll pass it through a function of your own where you can break down the statement. Like, for example, you expect that only a name should come, right? So you know that, okay, a name is not going to be maybe more than 3 or 4 words, right? Why would a name come with 6 words? Number one. Number two, a SQL statement can have special characters inside. So you can detect, okay, can I see any special characters inside this input, that request that's coming in? Oh, okay, there is one. So I think there's something not right. So you can log that and then reject that request back, say, oh, there's an error. And then when you see the logs, you'll know, oh, somebody's been trying to fire SQL queries in my request. So there are a lot of libraries available now. You can just use it for that. Or if you use API gateways or maybe, security firewalls, they will detect all of this for you because they have the algorithms inside to detect this. So SQL injection is a pretty normal thing, because we as a developer, we don't understand, and we assume when we code, it'll always be a success case. So we also assume that when a user is using the application, oh, they're going to be good users. They're never going to actually, mess around with our application. So that's basically what you call about sanitizing the input. So you're trying to clean it up as much as possible. Similarly, I mean, the most basic way of sanitizing input is if someone sends blank spaces, right, before a name or before a word and after a word, you want to trim it down, right? Because you don't want to store it as part of a space. So you're basically sanitizing the input over there also. Different ways, but usually from a malicious perspective, when you say sanitization, you're talking about stuff like detecting any request that is not supposed to be there, right? Or somebody sending a payload that is not supposed to be there. In this case, I'm not sure if you've heard that there's a very famous. Let me see if I can find that. XKCD, an XKCD SQL joke. Yeah, so this is basically a joke, and this makes sense because a lot of your applications would look similar, right? So basically, there's a mom being called from school, and then they're saying we are having some computer trouble. What's the problem? They're saying, did you actually name your son, Robert? And then you can what they're doing, they're escaping this and putting a semicolon and then firing a second query as part of the query, right? So drop table students, bam, the table is gone. This is basically how you do it. So this is where they're saying, okay, I hope you sanitize your database inputs. So as a developer, a lot of times I'm surprised when I also talk to people, and a lot of them don't actually look at this because they take it for granted. They assume that everything works all right, but it doesn't. You need to always assume that any input that comes in has to be checked and verified. So whether you use a security firewall or whether you use something else, you need to always keep that in mind. So I'll just put this link over here so that if anyone wants to refer to it later, they can. And if you want to test this out, you can do it yourself. Just have a look at how to delete this through a request. Go and build a simple PHP MySQL application and then try it out yourself. Just don't do it to other people's applications. That's all. That's all I can say. Awesome. So yeah, I mean that's basically it. I don't see any other questions over here. So guys, I mean, do you have anything to say? It's been a long journey.
Yeah, it's been a long journey. We take some break and hopefully we come back stronger with something more, hands-on.
Right.
So, yeah.
Yeah, we'll start looking at going more hands-on. I think the whole idea of building blocks, keeping this information out there on YouTube, is that so that anyone can refer to it anytime they need to. So now when anyone wants to learn about the cloud, they don't actually have to say, hey, actually, I don't understand anything. There's a lot of content. I mean, enough 3 months of content already available over here. So just do go back to that, and especially the content that was presented by our guests, because they brought in a lot of their experience to show you how things can be built. So yeah, I mean, that's basically how it is. So we'll be taking a break from here, and we're already planning for the next big thing. So we'll keep you all posted. Again, like I said, the Telegram group, most of you are viewing is already part of it. We don't bite, so do keep it lively. Do ask questions if there's something you want to learn, something you want to know. the best way you can learn is only by asking questions and trying out things. So do try that out. We'll be sharing some things in the future soon when we start getting our next content ready in terms of application development and deployment. So we'll do that. So with that, I mean, thank you so much, everyone. Thanks to especially to folks who have been with us since the beginning, seeing every session, and supporting the series for quite some time. So hope to see you all very soon. Maybe a Friday, maybe a weekend. You never know. Peace and have a safe weekend in MCO.